right? Grade 11s, we are going to do functions, and in this lesson we are going to be looking at the quadratic function or the parabola, right? So we are going to be looking at the quadratic function. So you see that at grade 10 you worked with the function y is equals to ax squared plus q. So these parameters a and q had certain effects on the graph. The value of x determined whether the function had a maximum point or a minimum point. So if a was greater than 0, then we know that the graph is like a smile and the function will have a minimum point, right? So it will be a smile. And then if a is less than 0, then the graph will have a maximum point and it will have a frown. So we can talk about frown and a smile. And then the value of q determines how many units the graph moves from the origin vertically, right, up and down. So if your q is greater than 0 or positive, the graph moves q units up. And then if your q is less than 0 or negative, the graph moves q units down. Okay, so this was grade 10. Let's just look at an illustration of these parameters, right? Example, let's say given the function f of x is equals to x squared, we are going to sketch different graphs to do an investigation or show the effects of a and q on the graph. So we draw our Cartesian plane there. We've got our x-axis and our y-axis. So we are going now to sketch different graphs. So we start with the graph f of x. F of x is the parent graph, right? And then we draw now another graph which we call g of x. So we see with g of x, the arms or the curves become steeper because we have increased a. And then when a becomes negative, you see that the apparent graph is reflected about the x-axis and it will have a maximum point. And then if we draw the graph j of x, where we have increased the parameter q, the graph is shifted upwards. And then if we draw k of x we reduce q is negative, the graph moves downwards, right? And then you will see that here all the turning points of the graphs we learned in grade 10 were always on the y-axis, and also the shifts that happened were that of a and that of q. Okay, so that is all grade 10 revision. You must know this. Okay, so if you don't know it, we have explained it again and you need to do some questions. So let's look at an example, right? Let's look at different graphs actually. So graphs of y is equals to ax plus. So you see these types of graphs, we did it when we were doing completing the square. So we say that this quadratic is written in completed square format. So we can say these functions or quadratic functions are written in completed square format. So we are going to sketch again different graphs. We start with the parent graph. There it is, and then we draw g of x, where we've increased the parameter p. You see that we've reduced the parameter p actually, and the graph shifts to the right. And then if we increase the parameter p and make p positive, you see the graph will move to the left. And then in the function j of x, we reduce p and increase q. You see the graph moves to the right and 1 unit upwards. And then when we do the function k of x, you will see with k of x we reduced both parameters q and p, and the graph shifts to the right and 1 unit downwards. And the graph m of x, you see that we have made a negative, which means it has got a maximum point, which means like the graph is reflected about the x-axis. And then we increase the parameter p, which means the graph shifts 1 unit to the left, and then we reduce q, where the graph moves 1 unit down. Okay, so these are the effects. Let's summarize these effects of a, p, and q. So we can say in summary, effects of p A, P, and Q on the graph of y is equals to A, open bracket, x plus P, close bracket, squared, and y is equals to that. So the completed square format of the quadratic. So the parameter A is still, the effect is the same as the one we investigated in grade 10, or we determined in grade 10, is that it determines whether the function has got a maximum or a minimum point. If x is greater than 0, then minimum point. X less than 0, maximum point. And then the parameter variable, the value of P, affects the horizontal shift of the function or graph. If P is greater than 0 or positive, the graph shifts P units to the left. And if P is less than 0, the graph shifts P units to the right. Okay, and the effects of Q are the same as in grade 10. The value of Q affects the vertical shift of the graph. If Q is greater than 0, that is positive, the graph shifts Q units up. And if Q is less than 0 or negative, the graph shifts Q units down. So you can see A, it's all about the smile and the frown, right? If A is greater than 0, it's going to be a smile. If A is less than 0, it's going to be a frown, right? A greater than 0, minimum point. A less than 0, maximum point. And then for P has got a horizontal shift effect on the graph. If P is greater than 0, that is positive, the graph moves to the left. Be careful there, it moves to the left. And if P is less than 0 or negative, the graph moves P units to the right. And then the value of Q has got a vertical shift effect on the graph. If Q is greater than 0 or positive, the graph shifts Q units up. And if Q is less than 0 or negative, the graph shifts Q units down. Let's look at some examples so that we can really understand what's going on. So before we do that, let's look at steps. Let's summarize. How do you sketch the graph of y is equals to ax squared plus b of x plus c, which is the standard format, and then the completed square formats? So when you are drawing these graphs, the first thing that you do is you write down your a. What is the value of your a? Remember, the a, if the a is less than 0, right, it's a maximum point or a frown. If a is greater than 0, it's a smile. So this happens for all forms of these functions. And then step number 2 is to find your x-intercept. You know x-intercept, y is equals to 0. When it's written in standard format, your x, you are going to use your quadratic formula. And then if it is in completed square format, our x will be equals to negative p plus or minus square root of negative q all over a. So if you know this, you just substitute in everything into these formulas and you will be able to find your x-intercepts. Remember, if the function does not cross the x-axis, you will not find the value of x. So there will be no solution for the x-intercepts, right? So you have to determine in where does it lie. Does it lie below the x-axis? If it is a frown, or if a is less than 0 and it lies below the x-axis, then it will not have any x values. If a is greater than 0 and it has got a minimum point, it's a smile, then and it lies above the x-axis, then it will not be having any x-intercepts. So step number 3 is to find the y-intercepts. Remember, the y-intercept x is equals to 0. So in the standard format, it's going to be y will be equals to the constant c. And then in the completed square format, it's going to be y will be equals to ap squared plus q, depending if the q is there, right? And then step number 4, that is when we look for the turning point. So to find the turning point, we are going to say our x will be equals to negative b all over 2a. So you just take the value of b, you multiply it with a negative, and you divide it by 2 multiplied by the value of a, and then you find the x coordinate of the turning point, and then that one you can then solve for y, substitute the value of x into the equation and solve for the y coordinate. So for the completed square format, it's going to be your x will be equals to negative p. So you take the value of p, you multiply it with a negative, that will be the x coordinate of your turning point, and then your y coordinate will be y will be equals to q. And then after finding the turning point, the next thing is to look for the line of symmetry, right? So the line of symmetry, you see, the important thing with the line of symmetry is that it divides the whole graph into two equal parts, and usually once you have the one x coordinate, you can use the line of symmetry to find the other x coordinate or a root. Remember, what you must keep in mind is that the roots are equidistant from the line of symmetry, which means they are of equal distance from the line of symmetry, or we can say the line of symmetry, it's a midpoint between the two roots. Okay, so our line of symmetry is usually the x coordinate of the turning point. It's always certain like that. And then after you have all this information, you can sketch your graph, because you just know what a tells us, helps you to determine the shape of the graph. And then the x coordinates, you plot it down, you plot down the y coordinate, you join those points, keeping in mind the shape which is dictated by the value of a, and then you can now put in your line of symmetry. Let's do some examples. Right, example number 1, you say sketch the graph of y is equals to negative open bracket x plus 1 y squared minus 4. So you can take the value of a is equals to negative 1, which means it's going to be a is less than 0, which is a maximum point. It's a frown. Step number 2, we find our x-intercepts. We say y is equals to 0, and then we solve for x. In this case, you see that we can't find the real solutions, right? Step number 3, we find the y-intercept, which is going to be x is equals to 0, and we solve for y. So our point y-intercept is 0 and negative 5. And then we find the turning point. The turning point is going to be negative p, which is negative 1, and q, which is negative 4, and that is our turning point. And then our line of symmetry is x is equals to negative 1. And then we plot. So plotting is not drawing something to scale, but giving a rough idea of how the graph looks. So determined by the dictated actually by the value of a, we know that is going to be our turning point will be a maximum point. So we sketch it like that. Okay, let's do another example. Right, example 2, sketch the graph of y is equals to 2x squared plus 4x plus 1. So step number 1, a is greater than 0, is going to be minimum point, right? Step 2, we find the x-intercept, y is equals to 0. So we solve for x. Here you can use factorization, or you can use your quadratic formula. So using quadratic formula here, because you cannot easily factorize it, we see that x will be equals to negative 1.71 or negative 0.29. So our intercepts, we have got 2 intercepts. And then our y-intercept, x is equals to 0, step number 3, and we solve for y. So y-intercept, there it is. Step number 4, turning point. So our turning point, there it is. Right. And the x will be negative 1. You can see we just use the what we got there from the summary, negative b all over 2a. We substitute the value of 4 of b, which is 4, and the value of a, which is a 2. And then we simplify, our x will be equals to negative 1. And then we substitute into the equation to find the value of y. And then our y is going to be negative 1. So our turning point is negative 1 and negative 1. And then step number 5, they say line of symmetry. So our line of symmetry, remember, is the x-coordinate of the turning point. And then we draw our Cartesian plane to sketch the graph. We put our x-intercepts, then our y-intercept. Right, there we go. So basically, we put our, so we are going to put our x-intercept, then our y-intercept, and then the turning point. Then we draw our graph. There we go, and our line of symmetry. Okay, moving on to example number 3. Example number 3, sketch the graph of y is equals to x minus 3 close bracket squared. Our a is greater than 0, it's 1, so there is going to be a minimum point. Step 2, the x-intercept, y is equals to 0. We solve for x, our x is equals to 3, so intercept is 3 and 0. And then step 3, our y-intercept, x is equals to 0, our y will be equals to 9. And then step 4, turning point. So remember, our x is equals to negative p, which is positive 3, and y is equals to q, which is a 0, because there's nothing. So turning point, there it is. And then our line of symmetry is the x coordinate. X is equals to 3. Right, now we can sketch the graph. So we put our x-intercept, our y-intercept, and then our turning point is the same as our x-intercept. And then we draw our line of symmetry. Remember, the line of symmetry cuts the graph into 2 equal parts. And then the next one, example number 4, they say sketch the graph of y is equals to 2x squared plus 12x minus 16. Our a is less than 0, which there is going to be maximum point, which is a frown of a graph. X-intercept, y is equals to 0. Then we solve for x. So again, here you can do it like that and factorize. This one is a simple one. Our x is going to be 2 and 4. So those are our intercepts, 2 and 0 and 4 and 0, our x-intercepts. Y-intercept, then our y will be equals to, we substitute the value of 0, x is equals to 0, and you see your y is 16. So x-intercept is 0 and negative 16. Step number 4, turning point. Remember, our x will be equals to negative b all over 2a. We substitute those values, we get our answer is a positive 3. So our y, we substitute into the equation, y will be equals to 2. That is our turning point. Step 5, line of symmetry is going to be x is equals to 3. And then we sketch the graph. So our x-intercepts first, and then our y-intercept, our turning point, then we draw the graph and the line of symmetry. So what I was telling you there, remember, was that the distance from here to here is equal to the distance from here to there. Okay, so the roots, which means the x-intercepts, are of equal distance from the line of symmetry. So the next lesson which is going to come, we are going to look at the equation of a hyperbola. Okay, right, see you in the next lesson.